Hey, welcome to Academic Solutions, Making It Easy. My name is Refila Matilola. I'm your tutor for the subject Physical Science. Today we will be discussing a new topic, um, following up from where we left off. The new topic, I think it's about, we did thermodynamics the last time, and today we'll be discussing electrolytes. Chemical reaction, electrolytes. What are electrolytes? Electrolytes are substances which dissolve in water and produce a solution, a mixture of a solid and a solvent that conducts electricity due to the presence of ions formed by dissociation are called electrolytes. Anions are negative ions and cations are positive ions. Dissociation of ions. Uh, Dissociation is formation of ions, meaning cations and anions. When ionic compounds dissolve in water, the anions and cations are separated from each other. The process will a salt ionic compound such as a salt chloride will dissociate into sodium cations and chloride anions. The sodium chloride is dissolved in water. However, water is not known as a reactant because this is dissociation. Water is a solvent while the ionic compound is a solid. The equation is below. Sodium chloride reacts, dissociates to form sodium anions and chloride anions. Note: take note of the following subscripts. The sodium chloride is a solid at first. When it's dissolved in water, it dissociates because it is an ionic compound and it is soluble in water. Ions of sodium chloride are formed and their subscripts are aqueous. This is because they are now inside water. When a soluble ionic compound dissolved in water, the solvent and solid water, in this case particles, attract each other. Before a solution can form, the electrostatic force of ionic compounds must be overpowered. Note: a molten sodium chloride solution can conduct electricity and a solid sodium chloride cannot conduct electricity. But if it is dissolved in water, like here in the example, you can see the dissociation happening. The chloride anions are going to the anode and the sodium cations are going to the cathode. When sodium chloride is dissolved, it can conduct electricity. Continuation of notes: when electric current passes through a sodium chloride which has been dissolved in water, it is broken down into sodium and chloride, which is what we saw on the previous image. The light glows and yellow substance chloride is observed. The positive sodium cation is found on the negative electrode, while the chlorine electrons will be attracted to the positive electrode. The process of a compound broken down by electricity is called electrolysis. However, since water also participates in electrolysis reaction, a sodium hydroxide aqueous solution is formed. In addition, a hydrogen gas at the negative electron. So we see the reaction from the previous image. It's Sodium chloride reacting with water, it gives H2O, which is the gas, and when it dissociates, it gives hydrogen gas and also gives chlorine and sodium hydroxide. Notes. Sodium chloride is a well-known electrolyte. Continuation of known substances which can conduct electricity. As we know, the substances which can conduct electricity, they are when they are molten or when they dissolved in water, they are electrolytes. Other examples of electrolytes are potassium bromide, copper sulfate, sodium hydroxide, and zinc nitrate. Hydrolyzed salts. When an acid and base react and neutralize each other, salt is one of the products formed. Hydrochloric fluid, HF plus NaOH react to give NaF and H2O. When a weak hydrofluoric acid neutralizes with a strong base, sodium hydroxide, the salt sodium fluoride forms. Another example is HCl, which reacts with sodium hydroxide and they give sodium chloride and H2O. HCl is a strong acid and sodium hydroxide is a strong base. When these two react, they form a salt. The salts formed are either strong or weak electrolytes. Sodium is a salt of strong acid and base, does not undergo hydrolysis. Sodium chloride is a salt of strong acid and base and does not undergo hydrolysis, hence a neutral solution. Conductivity of soluble salts. For a salt to dissociate, it must be soluble in water. Solubility rules help us determine which type of salt is going to be soluble in water. Pure water cannot conduct electricity. The electrodes read 0A current when there is only pure water. This means that the light bulb on the circuit does not glow. However, when a soluble salt is dissolved, electrolytes, the anions of salt are formed. The light bulb either glows dimly or shines brightly. Presence of ions and their movement causes the current to flow, just as the movement of electrons in metals makes it possible for them to conduct electricity. Sodium chloride is a strong electrolyte and the current reading will be high, causing the bulb to shine bright. Okay, there's two types of salt formed by a strong acid and a strong base. It gives a neutral solution. Like you saw previously at the previous example where a strong acid, hydrochloric acid, and a strong base, which is sodium hydroxide, when they formed, they gave a neutral solution. So when a strong base reacts with a weak acid, it gives an acidic solution. When a weak acid reacts with a strong base, it gives a basic solution. Okay, let me repeat that again. When a strong acid reacts with a strong base, it gives a neutral solution type. When a strong base reacts with a weak acid, it gives an acidic solution type. And then when a weak acid reacts with a strong base, it gives a basic solution type. Solubility in water, rules of salt. Nitrates, chlorates, and acetates are soluble. However, acetate is sparingly soluble. Sodium, ammonium, and potassium salts are soluble. Sulfates are all soluble excluding lead, mercury, barium, and calcium, and silver sulfate is partially soluble. Carbonates and phosphates are partially soluble. Hydroxides are very soluble. Potassium hydroxide, sodium hydroxide, and barium hydroxide, they are very soluble. Chlorides, bromides, and iodides are soluble excluding lead compounds and silver mercury. Silver nitrate is soluble. Conductivity of salts. Most salts are good electrical conductors. They can conduct electricity due to the motion of charged ions in the solution. Acids as potential sources of electrolytes. Strong acids are good electrolytes. Hydrochloric acid, uh, bromine acid, uh, sulfuric acid are examples of sodium acids, and they are good electrolytes when molten or dissolved in water because ions which are present on the solution, they completely ionize. Ionic substances which are formed by acids are good electrolytes. For example, HCl plus H2O form H3O plus chloride ion. The presence of the chloride ion and the H3O ions make this acid a good electrolyte. Ionization. Ionization is a reaction in which a polar covalent compound is converted in a new ion in water. In the reaction above, new substances are formed and the process is called ionization. Displacement reaction between electrolytes. Displacement reaction is a type of reaction where one reactant replaces or displaces another in product. A reaction between two soluble salts which react to form an insoluble salt is called a displacement reaction. These reactions can be used to identify anions in a solution. Testing for halides. To test the halides salt or silver nitrate solution is used. Chloride, a white cloudy precipitate forms. Bromide, a pale cream precipitate is formed, which is silver bromide. Iodide, a pale yellow precipitate is formed, which gives a silver iodide. Fluoride, no precipitate is formed. You get silver fluoride. Equation of displacement reaction. Here we have silver and bromine, which gives us silver bromine. Note that the sodium chloride and NO3 are spectators, hence they are not included in the equation. And then we have what we call corrosion. Corrosion is a process which occurs naturally where reactive metals form oxides, hydroxides, or sulfide when exposed to air. Testing for sulfate, a barium chloride solution is used and the result is a white precipitation is formed. The equation is barium chloride and MgSO4 equals Mg Cl2 plus BaSO4. This displacement reaction enables us to test for SO4 sulfur. And then we have what we call rust. Rust is a result of iron oxide bonded with water, which speeds up the process of corrosion. It is when a material undergoes redox reaction of iron and oxygen where where water is also present. The rust is an iron oxide and it's usually forms on steel or iron surface. Forms on steel or an iron surface. How to prevent rusting. Galvanizing can be used to prevent rusting. Zinc metal is used to coat the surface of the rusted steel or iron metal. The zinc reacts instead of the iron or the steel, and even when it becomes exposed, it gets damaged. The steel will not be affected. That's the end of the topic for today.